Thank you very much. Hello and welcome to our talk, which is about extending a legacy platform, providing a minimalistic, secure, single sign-on library. But before I explain what that actually means, let me introduce ourselves. We're here in behalf of the Research Studios Austria, Forschungsgesellschaft, more precisely for the studio Microlearning and Information Environments. So the title of the studio already suggests that this has usually nothing to do with security research. Actually, my research field usually is technology-enhanced learning. Sebastian is a student at the Johannes Kepler University in Linz. And we did a project together, which was on knowledge management platform. And we had to extend an existing platform seamlessly. And in the course of this project, we came across a problem, which is the reason why we're here. This problem was a security problem, and we want to present this like real-world example. The problem was that the system that was given was a legacy system with approximately 12,000 existing accounts, which continuously changed, so there were new users registered, or others were deleted, and credentials changed. It was a closed registration system, so there's no open registration, and we could not implement the solution directly in this to extend the system directly, so we had to use a separate system and integrate those systems via single sign-on with the use of the existing accounts to authenticate the users to the third-party apps, in this case our knowledge management platform. But we, as I later will explain, chose an approach that is more general so that potentially future third-party apps can also be integrated. So single sign-on is not a very new topic, and there are there has already been a lot of thought into this, and I think especially SAML should be really well known. There are several standards, and first of all, let me just talk about those standards briefly, so that we get a good idea why we chose to not use those standards. So SAML, Security Assertion Markup Language, actually describes the document standard that is used for the security token. It's claim-based authentication, which works basically in the way just briefly explained. You have an identity provider that issues an assertion, which is digitally signed to provide authentication and message integrity. And the service provider who trusts the IDP validates the signature and grants authorization based on these assertions. I won't go more into detail, as probably anyone here will know in more detail what SAML is all about, and about the many possibilities what you can do with SAML. Newer format, so to say, which covers a part of what SAML is intended to, is JWT, JSON Web Tokens, and it's a more compact, all-safe representation for claims. It is self-contained, so you have a header stating things about the methods used, then you have the claim set and the signature, which verifies the claim, or can be used to verify the claim. It is less flexible, but much simpler than SAML, and would have been much more appropriate than SAML for our use case. It is used by OAuth 2.0 and in OpenID Connect, for instance. The problems, or let's say, what we found out about standards implementations is that it's always easy to implement a service provider once you have an identity server running. So it's easy, cheap, you have many libraries and frameworks to choose from, and you just go ahead and attach your service to an existing identity provider by using one of those frameworks or libraries. But what's not that easy is to implement an identity provider, as identity providers that comply to the standards need to fulfill a lot of requirements, and also if you're not doing it properly, that leads to security vulnerabilities, and that's a problem. They tend to be very heavyweight, complex, and most of the things you find for identity providers are full software solutions, so you get a standalone identity server, and you can have your identity server to manage your identities, and then have a lot of service providers. So, generally speaking, standards try to cover almost every use case and tend to get, therefore, a bit complex and bulky. In our case, we just wanted to add the basic capability, the basic idea, to an existing system, so to say. The legacy system needed to be our identity provider in this case. Previously, the company we were doing this project for had no single sign-on. They used a different approach to authorize third-party services. They had a backend web service where they just queried whether it is a valid user and if the password fits for this user. So they basically sent, I have here a person claiming that he's that person and providing that password. Is this correct? And the web service basically said yes or no. That leads to some problems. The web service is protected just with static API key. Once you know the key, you can do whatever you want with the service. The password is sent in clear text, and you have no control over what the third-party app does with the password. So the third-party app basically can store the password and use the legacy system on behalf of a different user. So this was not an option for us. And furthermore, it was not seamless as it's not single sign-on. Our chosen approach used the basic ideas of the existing standards, but only selected parts so we could focus on what's essential. It's claim-based. We have a simple issuance by our custom identity provider. This claim is then signed and encrypted. We use the post binding to transfer this claim. I will show the flow in a minute. And we thereby provide an additional security layer on top of TLS. So this is the authentication flow. I hope looks like one could read it. It starts here with the user who types in the URL of the service. The browser opens the service provider site. The service provider site creates a claim request, which contains a nonce for later prevention of replay attacks. This this claim request is redirected to the IDP, which checks if the user is already logged in. The IDP, as I told, is in our case the legacy system. And if the user is logged in, or if the user is not logged in, he has to enter the credentials. He's displayed. The browser displays a login form, and then once the user is logged in, the identity provider issues a claim, and the browser redirects the claim to the service, and the claim is validated on the service provider side. And if the validation fails, you get an authentication failure message. And if the claim is valid, you get authenticated, you get your privileges granted, and you're signed in. Okay. That was a brief overview, and now we'd like to go into the details of the implementation. Therefore, I hand over to my colleague, Sebastian.
Hello, okay. Well, thank you, Bernhard, for this part of general introduction of our problem. And I will come to the more concrete stuff, so how actually we did the implementation. First step, when the user is at the service provider, where you actually want to consume services, our library first generates a random one-time secret for symmetric encryption, so-called nonce. This nonce has to be attached to the user session to detect replay attacks, so that the service provider knows exactly which user has which nonce. Second step is to encrypt the nonce and the return URL with the public key of the IDP, so that only, and really only, the IDP should be able to decrypt this. So the nonce is kept secret and only available for the IDP. Outside the library, you send the nonce and the return URL, both encrypted, to the IDP. Now I show you a snippet of how you use the library that we developed. As you can see, is it implemented in PHP, but it's not that big deal to implement it in any other languages like C# or what you prefer. So basically, you have to instantiate a service provider and call the method prepare redirect. To this method, you just pass the parameters, the public key of the IDP, so the identity provider, and the URL you'd like the user to call afterwards he or she has authenticated at the identity provider. As a result, you get SP data, and in the comment you can see it contains the nonce in clear, the encrypted nonce, and the encrypted return URL. As I said before, the unencrypted nonce has to be kept in the session so that later on the service provider recognizes the user and checks the nonces. The encrypted nonce and the encrypted return URL are then passed to the identity provider. Which leads us to the second step. So now we are at the identity provider. In our case, it is the legacy system where the user can authenticate with username and password. If the user has successfully logged in, so typed in username and password and it's correct, our library comes back into game. First, you decrypt the nonce and the return URL. Then, you, as an identity provider, you select the information you want to pass on to the service provider based on the URL that you decrypted. So you could have multiple service providers and pass on different information. As I said, you got this information and then you calculate a signature out of it to later give the service provider the opportunity to check whether this is signed or not. Then you encrypt the user info with the nonce, so symmetric encryption. And finally, you encrypt the nonce with the public key of the service provider. So again, only the service provider should be able to decrypt the nonce because it is asymmetrically encrypted. After doing that, outside the library, you send signature, encrypted nonce, and encrypted user info back to the return URL that was passed. So again, how do you use the library? Like before at the service provider, you instantiate the identity provider, and you call just one single method, prepare redirect. You pass on the private key of the identity provider, so legacy system, and the public key of the service provider, system that wants to consume the information. The JSON encoded user info, so information about the user, depending on the return URL, the encrypted nonce, and the encrypted return URL. Output of this method is again an associative array containing the encrypted nonce, encrypted user info, signature, and return URL. The first three are sent back to the service provider. The latter one is just used to forward back the information. Last step, so user has authenticated at the identity provider, and we are back at the service provider. The first step is decrypt the nonce. Then you have to check whether the initial nonce is equal to the nonce that has been passed from the identity provider. If the two matches, everything's fine. If not, just abort. Second step, decrypt user info with the passed nonce, symmetric encryption. And then you have to check, does the user info meet the signature, or has something been modified? So that's basically it, and the method returns the user info that the service provider wants to have. Last time, how did you use this? Again, you just instantiate service provider and call the other method, check authentication, pass two keys, one public key from the IDP, the private key from the service provider, the remembered nonce stored in session, the encrypted nonce and the encrypted user info, and also the signature passed by the identity provider. The result of this method is either JSON claim, so user information, or it returns false, so abort, something went wrong. Good. To give you a better understanding, we have prepared some live demo. Here you can see a very old-fashioned legacy system that allows the user to log in, register, and make some changes. So I will just register a new user called Demo. Yoo-hoo, I've created a user called Demo. I will set some profile picture and infos about me. Here we are. It is stored at the legacy system, so the identity provider. Logging out. Then I go to a service provider, which you evidently see it's modern and it just reuses the old legacy platform. To give you a better understanding what is happening in the headers. Or is it network? No. There it is. Yes. So I have here my service platform, and I want to sign in with the legacy platform. We're here in the legacy platform, and if here you can see, at the parameters, we have passed on, like we discussed before, the encrypted nonce and the encrypted return URL. So I'll log in. Here we see we are at the web app. already in content. Here you have infos about me and the picture. So it obviously worked. What has been going on behind the scene? We have been redirected to index.php at web app. This was the callback URL. And the encrypted nonce and the encrypted user info have been passed on, as well as the signature. So everything worked fine. Logging out. Well, that was our live demo. Result and conclusion. So during our project, we developed a minimal single sign-on library, which is, as you can see here, really very minimal. It's not even 300 lines of code, and if you take aside blank lines and comments, it is even less. If you like to, you can have a look at it at the URL which is displayed at the screen. Yeah, I hope somebody will use it or take it as a chance to improve the systems that are there. Conclusions, single sign-on does not need to be a hassle. So to get a clean solution, it is enough to follow some guidelines or general, how to say, yeah, just some guidelines or standards, and you get clean solution with reasonable effort. The legacy system as IDP is feasible and also reasonable because building up a system from scratch is much more cost intensive than extending a platform like we have presented here and use it as an identity provider. I hope I didn't forget anything, and I'd like to hear some questions. Thank you.
So, jetzt Mikro rüber.
Questions?
Okay, thank you for the talk. I wanted to ask why do you actually do encryption of these nonces, and why do you need encryption at all if you use TLS below?
The fact is that TLS, as we have heard in video recently, could be broken.
You have to talk in the micro.
Okay.
No, let it on. Just use the micro.
This one?
Yes.
Okay, so the idea is that you can attack and break TLS security as well. So the costs were reasonable, and it just provides an extra layer of security. You might argue that it's not necessary, but we chose to nonetheless implement it, as it was just it didn't really cost performance, so it's still working very performant, and we just decided to do that to add an extra layer of security.
Further questions? No? Question from myself. Did you think about enforcing in some kind of way, doing a transition to get rid of the legacy system sometime in the future? Because while I kind of like the idea of single sign-on, because usually users like it, this somehow makes me think, how long is this legacy system going to stay even longer there? Is there any thoughts you have on that?
I don't think that you can answer this in general. In a concrete example, it's not to our responsibility how long the legacy system stays, is kept alive. We just have to provide a hopefully secure solution.
Yeah, in this special case, we know that the legacy system will be around quite some time, because it's the organization, so to say, is not a corporate organization, and has very limited budget, and it was a one-time investment in the system, and they have it and they will have it around for like, I'm sure they have it around in 10 years as well. So